Okay, all right. Um, Quick check. How many of you are cyber experts? Just a quick raise of hands. Either from product side, tech side, sales side, anything, but like you really know cyber well. So that's pretty much. All others are engineers, software developers. How many of you are software developers or senior software or engineering managers and things like those? Okay, and the rest of the folks who are sitting here are students? Oh, how many of you are students? Oh, wow. Oh, all right, great. No, that's good to see. One quick fact check. How many of you, maybe not a fact check, maybe an opinion, how many of you believe what's the safest job today in software industry? Anyone? Cyber. Yeah, look, we can't expect any other answer, than this from Anirban, but yeah. Anybody else wants to take a guess? AI engineers? What else? Okay, let me start with this. How many of you believe UI engineering is the safest job today? When I say UI, HTML, CSS, React, front end, things like those. Zero? Nobody believes into it? World is over for them? Okay, all right, great. How many of you believe that UX designers are the safest job? Okay, are you a UX designer? No, not really. Why do you believe like that? Sure. Okay, all right. By the way, UX now can be generated through prompt. If you don't know UI's art, go to UI's art, put a prompt, and it gives you all the wireframes, just like that. Okay, how many of you believe the backend engineers, right? Node, Express, Java, Python, blah, 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 and so on. It's safe? How long do you think they can be safe? Is all in backend, but let's say if you put cyber out of it, just regular backend. Nothing is safe. That's a good. All right. Uh, yeah, look, with the advent of AI, a lot of things are at risk. But my personal opinion and belief is that cybersec is something similar to our physical industry, like education, healthcare, and food. They're not going to die. Like we need those three things every point in our life. Even if robots come in, they may not need it, but we'll always need it, right? As an example. So I think cybersec is one area where, with a lot of advancements in technologies, cybersec is going to stay relevant for a long time to come, right? It may be in different forms and shapes. The technologies themselves would be boon or curse for cybersecurity, but that makes it more interesting, right? So all of the students, I think 90% of our audience sitting over here, I think you should take cybersecurity very seriously from an engineering standpoint. I wish in engineering colleges like you have com science, electronics and telecommunications, and things like those, I wish, and even AI, by the way, a lot of colleges have AI courses and specializations. I wish cybersecurity should be one of the most prominent course, and just not a course, a specialization which comes from third year to final year, even from the first year. I think it's a need of an hour wherein all colleges also and the education policy makers should consider cybersecurity very important, because even for nations, it is very, very important, as few of my past presenters just talked about it. So, I think a lot of areas are covered in Anirban's presentation and also in Raj's presentation. I'm going to slightly deep dive, and I was like keeping my fingers crossed. Am I repeating my slides? Thankfully, they are not repeating. And hopefully you could learn something out of it. And I'm going to slightly deep down on current threat landscape. I think Raj has pretty much covered in most of his slides. But I think, as we all know, today organizations are suffering from ransomware attacks, right? And it's no brainer. Even without AI, this was a common phenomena. With AI, as we'll see, it will increase more and more. Phishing scams and social engineering, which Anirban talk about. I think every single day we're getting hundreds of calls. In fact, the AI technology is making it more worse. and I think Raj spoke about agents, and agents are becoming, pain in the ass, right? Because they're all automated. Uh, they can call anyone and everyone any point of time. They are 24 by 7, never sleeps, and they just keep on calling. They don't have any other work to do, but they don't realize that the other people have to sleep, right? And they're just calling and calling, and which is where this has become, and this is going to become more and more interesting and challenging, because as you infuse more and more agents in an organizations, and as those agents work for organizations which are supplier of products and services, that's going to become challenging from a phishing scam point of view as well. Data breaches, again, very common, and I'm going to quickly run through some of this because these are fairly covered in the previous presentations. Nation state actors, right? And espionage and cyber espionage, as you would have seen, is going to be very key, because as Raj mentioned, that it's a virtual arm range, and as many people say, that the wars are not going to fought on the ground, right? The wars are going to be all digital, thanks to AI. And you still wait for quantum. It's going to be massacre in the world when quantum comes up, right? And supply chain attacks, wherein companies like Zoho, who's part of the whole supply chain of vendors in terms of providing software products, and you could see a lot of attacks, not only on the products who are providing, but also organizations which are consuming, right? So this fairly covers the landscape of the threats which generally comes out from the cyber standpoint, right? All of us are on the same page so far, right? However, generally speaking, and as part of JP Morgan, as one of their MDs, we nice to spend millions of dollars on cybersec, right? But cybersec in organizations, whether you're a product company or a bank, you have to kind of look at from 4 different angles. One is the application security, right? As you write code, and as AI will write more and more code, protecting those applications from obviously your static vulnerabilities, from your dynamic vulnerabilities. How do you automate them? How do you verify them before they go to production? If you're not doing a good job, then obviously they get attacked and so on and so forth, right? So application security is one area, and very critical. Data security is another pillar, right? So you have databases, structured data, unstructured data. Many times organizations are not matured in their data policies, data governance, data warehouses, data intelligence, data lake, and so on and so forth. It's a massive world in itself. And that's one other key area when you look at cybersec standpoint. The third one is now cloud. And when I say cloud, it could be private or public. Your private data centers or public clouds like AWS, Azure, and so on and so forth. And there are a lot of players in just last 3 or 4 years. They become multi-billion-dollar companies just because they were only focusing on cloud security. And when you talk about cloud security, whether you're putting data on cloud, whether you're putting applications on the cloud, whether you're using a lot of other services of the cloud, like AWS has now millions of services, as part of their portfolio. So as you use them, how do you protect when you go to cloud, right? And infrastructure security, which is both physical as well as virtual. If you're building a data center, then you have switches, you have routers, blah, blah, and so on. So how do you protect all of those from cybersec attacks, right? So please remember that any and every point of time, when you look at cybersec from an organization standpoint, these are the 4 key pillars where you have to look at independently, because each of these has different ramifications. Each of these has different tools and solutions. Each of these has different attacks from the cyber standpoint, right? So from a technology landscape, we have been, so far pre-AI world, traditional solutions, which were firewalls, most commonly deployed solution, right? Antivirus software, which, my past presenters also talk about, and data loss prevention tools, right? I mean, fairly all of these were covering a lot of, cybersecurity solutions in your organization. As you emerge, AI, blockchain and quantum as well, which I've not put it. And I actually wanted a few slides on quantum, but I thought it would be too much. Maybe we'll keep it for the next, year session, right? So And we're going to cover largely on the emerging technologies and not traditional because that world is getting over now. But having said that, I think one common principle every organization has to keep in mind, and also one of the engineers, students sitting over here, is just go with zero trust security principle, right? What does zero trust security mean? Is that you just don't trust anything and everything, whether it's physical, whether it's virtual, whether it's AI agent, whether it's a human. The first principle is that I just don't trust anything. I don't even trust the vendors. I don't even trust the softwares I'm buying from the vendors. I don't even trust the privileged access people sitting in my organizations. I don't even trust the firewalls I'm putting up, right? So that's like pure play first principles. I just go with zero trust from verification standpoint, segmentation standpoint, monitoring standpoint, and things like those, right? If you have that principle outlined, then you can start working backwards. That now, what do I need to do? What tools I need to work with? What vendors I need to work with? What kind of people I need to deploy with, so that I can achieve my principle of zero trust, right? So zero trust lies the first foot forward before you look out even technologies like AI and quantum, right? From an AI standpoint, as all of us know, three broad categories: machine learning, deep learning, and NLPs. I'm not going to go more in details about it because these are fairly common terms nowadays. Each of these has different way of models which are designed. Each one of these has different types of trainings which goes into. Each one of these has different outcomes they are prepared for. But in cybersec, all of them are used in different ways. Generally speaking, from AI technologies in cybersecurity, threat detection is the most common area where AIs are getting deployed, which is where you are deploying AI algorithms to analyze the amounts of data, right? Because the threats have humongous amount of data which you have to go with, and you have to constantly analyze it, constantly identify suspicious attempts, right? And you have to alert security and potential threats around it. Now, this requires a lot of data, which is not only the public data but also private data, and all of data has to be crunched, using either machine learning or deep learning. There's less of NLP play over here right now because this is just analysis, and you have to start predicting. You have to start forecasting that what kind of events can occur or may occur based on all of this data what you're crunching, right? Incident response, which is where you have AI powered tools, which automate some of this containment and investigation and ramifications. And in this case, you can use some NLPs as well, wherein some people are saying, hey, go and respond to this particular incident. And the IT people or the cybersec people can have conversational bots, use NLP, and they start kind of responding to those incidences. Vulnerability assessments, as I said, from an application standpoint, from data standpoint, both static as well as dynamic, which is where a lot of AI systems are getting deployed, getting automated. In fact, in a lot of areas where the code is getting automatically generated, and with that, a lot of test cases are also automatically generated. That inherently covers your static, your SAST and DAST, coverage of your code, which means is both at the static level and at the runtime dynamic level, they're prevented preemptively, from the codes getting attacked eventually when you put them into production. And the security posture management, all the security information event management, which is SIEM, right? Systems can populate real-time visibility into security posture. And the security posture, again, sits on top of all the four layers, which is your app, your data, your network, your infrastructure, all of them, right? These are four key areas where AI technologies are getting deployed in various ways. Machine learning and deep learning are the most common ones. NLP is more where, as I said, a lot of conversational use cases between the people who are managing some of the systems and so on and so forth. But deep learning, I would say, is the most widely used, then machine learning, then NLP. And the reason is because deep learning is combination of neural networks coming together, right? So you can imagine you have different systems in an organization, you have different softwares, you have different hardwares. Each one of them have their own patterns. Each one of them is running their own machine learning. All of those models coming together, building a great deep learning network, and then you get a holistic picture of your security posture in an organization and how do you deploy AI for that, right? On the data side, data encryption using AI, where the algorithms can enhance the data security by making it more difficult for attackers, right? Obviously, with the advancement of quantum, this is gonna be becoming more and more interesting because the whole cryptography landscape is gonna change, and in the quantum industry, the regular RSAs of the world, the public-private key infrastructures of the world, they're just gonna collapse, and you're gonna have new key infrastructure management through quantum itself, which is going to be very different technology altogether, right? So in today's world with AI, there are algorithms using AI which makes it more difficult, more complicated to secure data. Obviously, with quantum, it will be a different world altogether. Anomaly detection, right? When your own people are accessing databases, or when your customers are accessing data or playing around with data or entering data, somebody could, malfunction with the data in terms of entering wrong data, right? Because you give forms in your application, now you have conversational chatbots, and I can constantly feed wrong amount of data, and that could result into a lot of other problems as well. So how do you detect those anomalies, right? And this data is all bits, and then how do you deploy machine learning on top of it? And when you connect a lot of these separate machine learning models, you create a large deep learning network around it, and find out what are the anomalies. Data loss prevention on the similar lines. How do you prevent data loss systems and block unauthorized data accesses, right? So generally speaking, for the student sitting here, when you have systems designed, you have various roles which you give to people to access the data, right? You have, like super critical administrations as part of your organization who have access to everything and anything. Then you have different sub roles which are for internal people and external people. And basis that, how do you prevent those data losses for various roles? And then again, similar applying AI technologies to prevent some of those accesses. For infrastructure protection, largely threat intelligence, which feeds and identifies potential threats based on current and historical data, right? So I think this threat intelligence is a massive data scenario, which I covered in my previous slide as well, because you not only have to work on your historical pattern in your own organizations, but you also have to find out the public information around it, and then you have to combine all of that together and you have to start forecasting, right? So I think the threat intelligence is where a lot of AI technologies are getting deployed, both on the cloud side as well as on the data side. Security patching, which is where the AI agents comes in, and for people who don't know AI agents, by the way, think about them as virtual softwares who are taking actions and who are thinking on humans' behalf, right? Or they're even doing it on their own. And then humans can just verify if required, which is called as human in the loop. So these are called as autonomous agents. You would have heard about RPA bots. How many of you have heard about RPA bots? Robotic processing agents. Okay, so the RPA bots were designed to take certain actions, but they were not designed to be intelligent to change the course correction if something changes in between, right? So there's, you can think about it as rule-based bots. So there were certain rules on which you wanted to function them. They go and do that job and come back. That's pretty much it. If you change anything in runtime, they would generally fail. Right? Here comes the agents, which is based on AI, who have the reasoning because now you have LLMs, right? They have all the methods to take an action. They can go call an API, they can call fetch data, they can send the data, they can think about what data it is, they can analyze, they can quickly run an ML model, do prediction, they can forecast, blah, blah, and so on, right? So they can do a lot of things. So you can think about all of this coming together. There was a vulnerability which got assessed. There was a threat which got detected. But these agents are continuously working on this. They're continuously analyzing it. They're continuously assessing it, right? And they have all kind of intelligence with them, which they can quickly patch up and upgrade without humans coming in the loop, right? As an example. So you'll see actually the agents. And if you follow Satya Nadella, look, every backend is going to get replaced by AI agents, is what a lot of people are saying. And I would believe so, right? And as every backend gets replaced by the agents, security is part of that framework. right? So every security action is going to be done by the agents as we move forward. In some areas of network as well, you have network traffic analysis, intrusion detection, and real-time threat detection, all very much similar to what you see, because the base principles around data application network all remain same, right? So, but you'll see in network analysis as well, where a lot of the AI agents are, also getting deployed. Um, I think we fairly covered this in a way. Some of the benefits and challenges, with AI. Obviously, as we discussed, AI can automate a lot of the job. You don't have to wait for humans to come, react, fix, patch it, and do a lot of other things, right? So AI agents or AI software or AI cyber softwares, they're constantly listening, they're constantly looking at it, they're constantly analyzing, and they're also autonomously working to fix it, right? So, however, some of the challenges remain, uh, because all the AI models are created by humans. Now, what if wrong data is fed to the models? What if the model outcomes are wrong? And if humans are not aware of it, who is using it, it can do different other actions, right? So AI bias, which is called as ethical AI, is one of the most significant risks, not only for AI generally outside cybersec, but it becomes more and more critical in cybersec, right? Because if the models themselves are not trained ethically, the outcomes of the models will be wrong, and that could be a, huge problem in the cybersec world, right? I mean, imagine we are saying all these AI agents are doing everything on their own, but the models on which they were working are trained wrongly because of maybe cyber espionage, and they won't fix it. They would just sit idle and they would have fun. You never know. Uh, Data privacy. Some of the cybersec AI softwares, AI agents, they themselves can be introduced for the data, and the whole governance and privacy of the data becomes very critical while training those models, right? And then explainability, which is similar to the ethical AI or responsible AI. Many times these models are black box, right? It is not like a software code wherein you go and change the code in the model and you're done, right? I mean, you have to retrain it, you have to give the new data, you have to find the outcomes, you have to run in the loop, blah blah, and so on, right? As opposed to just going and fixing a one line of code, you execute and run it, and it works. So explainability becomes a huge problem because this models becomes black box, and if they are black box, you don't know what's going within that model, right? So uh, first of all, there is a risk from bad factors, which is bad humans, and then there's a risk of the models themselves. And as you go more and more into AGI, which is where the lot of risk is what is perceived, is in the AGI world, AI is doing anything and everything, right? So how do you trust them? Which is where explainability becomes more and more important, especially in the cybersec world. Some of the challenges and limitation, again on the same, first slide which I talked about, adversarial attacks is one of the biggest risks in terms of AI, right? I mean, what happens if the one scenario we discussed, they're fixing it, they're working it properly. The second scenario we discussed that these AI agents are not doing anything because they've been trained like that. Somebody who was on weeds and trained the model just not to do anything, the model is not going to do anything, right? And the third area is where the AI agents are, taking wrong actions. Maybe it further amplifies the problem, right? Who knows? So the adversarial attacks is another key area, challenge in AI. However, having said that, as I said, it's a massive multi-billion-dollar opportunity. Cybersec alone, whether it is about network, data, app, cloud, infra, was itself was a multi-billion opportunity. AI is just amplifying it. And I believe that AI is amplifying it not because of automation. AI is amplifying it because the inherent risk with AI in cybersec are very huge. So to cover that, there's a lot of work which needs to be done of creating new tools. Is it like, is sometimes this is like you're feeding problems on your own to solve it. In Hindi mein we call it "Aa bel mujhe maar," right? So AI is like "Aa bel mujhe maar," right? So we are just fixing what we have created, and obviously that creates a new opportunity. But that's how the capitalist world works, right? So That's pretty much I wanted to cover. I wanted to cover quantum sec, but look, quantum sec is highly technical, and many people don't even know quantum computing as the area standalone, right? I mean, how does qubits work? How does entanglement work? How these two electrons at two distances can have same state? It involves a lot of physics understanding. And one thing I've been saying to all students is that in previous world, com, sci, and maths used to matter a lot, right? In the next world, AI and physics is going to matter a lot. So if you are not learning AI and physics, right, you could be in serious trouble in years to come. So for people who are newbies who are just starting, yeah, please have that understanding of your comp sci and maths. But a lot of that is going to be automated. And what you need now is AI and physics because the quantum world is just on the door. It's already taken foot in the door, by the way. And it's going to be a very interesting world. So I hope in the next annual event, we'll cover quantum security. And, I'm sure we'll be there. So thank you so much again for inviting me here. I hope this was helpful for both students and everybody else who's sitting here. Thank you so much. Are we taking any questions right now, or any maybe a couple of questions? Anybody, if you have, I can answer them. Yeah, please. I don't know if we can pass the mic, but maybe otherwise we'll have to be slightly louder. What we talked about are all the risk, right? And in AI industry, what is now been talked about is human in the loop, HITL. Which is where, because the advancement of these AI agents is coming along now, and they're going to be autonomous. Think about them as autonomous vehicles. Everything is done by the car. You're just sitting and enjoying, having fun. You're not even given the directions because map is taking care of it, right? But in the case of AI agents outside the automobile industry, human in the loop is where comes along for managing those risks, right? So, for example, imagine there is an AI agent who's been deployed for upgrading a security patch or applying a security patch. So before an AI agent applies the security patch, it sends an approval note to you. You verify all the inputs and outputs, and then you say approve, which is called as human in the loop, right? So your job is only just to manage the risk as a human, and accordingly make AI softwares or agents to work. For that, are we designing specific risk management softwares for AI? The answer is yes and no, because every tool which is slightly more matured is building human in the loop as part of risk management for their tool itself, right? But they're going to be bespoke, right? You're not going to have one single. Maybe in the future you may have eventually, but that requires a lot of integrations, and which is where there's integrations in AI world, both in cybersec, non-cybersec is a very huge industry again. But I think the belief is that a lot of this matured software companies, as they advance into AI and as they advance into more like AI agents, which are autonomous, they'll build inherent risk management in the form of human in the loop systems. Does that answer a bit? Okay, thanks. The data, the application, the network, the infrastructure, the cloud. And one thing is also an API. API generally comes as part of either application or cloud or sometimes even data, right? But it's common to everything. So the API security, data security, network security, blah, blah, and so on. Just go and start looking out what kind of tools exist. And as Anirban was saying, there are hundreds of tools, by the way, right? And it's very difficult to pick and choose because every tool has its own maturity. Every tool addresses some problems, there are feature gaps and blah, blah, and so on. But as I said, first principle, like an organization, even for student, when you look at cybersec knowledge and learning, just keep those 4 or 5 pillars handy. And for each of those 4 or 5 pillars, just start looking at what kind of tools, platforms, vendors exist and what they have to offer. And that itself is like, it'll take at least 3-4 years to just go through it and understand it and learn it. And which is where I'm saying that it is a need of an hour wherein right from the first year, in fact, even for school students, this should be a mandatory subject now. So. Yes. So for now, just get used to what exists today. Obviously world is evolving very fast and quantum is going to change a lot, but we'll rest it for the next year. Maybe that's a post graduation course. All right, thank you so much everyone. You have a nice day and interesting sessions coming out. Thank you.